Hi everyone, and welcome to Math Blossoms, where growing in mathematics is natural. Today's lesson topic is reflections on a coordinate plane. So this is another transformation we're going to study today. So let's get prepared. We're going to need a pencil today with an eraser so that if we make a mistake we can correct it. Paper to take notes. Also some graph paper because we are working with transformations. And a ruler or a straight edge is optional for this lesson. Remember to pause the video from time to time if you want to answer the practice questions. That is the best way to learn, is to try the problems on your own and then check to see if you get them right. And then if you don't get them right, look to see where you may have gone wrong so that you don't continue to make those mistakes. Also rewind the video if you need to review anything before you try to answer the questions. Okay, we're going to grow some vocabulary, but before we do, my name is Miss G, and we're going to do some breathing exercises just to get us going and to get us ready for the math lesson so we can focus and concentrate. We're going to breathe in through our nose and out our mouth, and we're going to hold it for 3 count. We're going to do this 3 times, okay? So breathe in through your nose. Hold it 1, 2, 3. Breathe out your mouth. Breathe in through your nose. Hold it 1, 2, 3. Breathe out your mouth. Okay, and the final breath, breathe in through your nose. Hold it 1, 2, 3. Breathe out your mouth. Okay, when I do that, I like to close my eyes, but if you don't want to close your eyes, that's perfectly fine. So at any time, if you feel a little overwhelmed or if you just need a little break from the lesson, feel free to stop, take a couple more breaths, and then start back up. Sometimes it just helps to get you more focused on what we're trying to do. All right, let's get going with some vocabulary now. The first vocabulary word we're going to talk about is coordinate plane, which is the graph you see in front of you. And it is a graph that's divided into 4 sections by 2 axis lines. Transformation is when we change the size, the location, or the orientation of a shape, or it could be a point or a line, by either a rigid transformation or a non-rigid transformation. So it's basically a process by which we change a shape or a point or a line in geometry on a coordinate plane. Origin is the center point in the middle of our coordinate plane. That point would be right here, and it is the point 0, 0. I made my little point very large there. The next one is x-axis, which is the horizontal axis that goes from left to right or right to left. And then the y-axis, which goes vertically up and down in the center here. Horizontal is left to right, and vertical is up and down. You could say down to up or right to left. It goes both ways. And then ordered pairs are all coordinate points, and they always start with x, then y. X tells you how far left or right to move your point, and then y tells you how far up or down, depending on if they're positive or negative. And then the last word is the type of transformation we're going to learn about today, and that's a reflection. A reflection is also called a flip, and it's when we take a shape or a line or a point and we flip it over a line of reflection. A line of reflection can be any line on the coordinate plane. However, for today's lesson, we're just going to use the 2 lines that are already there. The y-axis here in the middle, and also the x-axis that goes horizontally. All right, there are 3 lesson essential questions today. The first one is, define a reflection on a 2-dimensional coordinate plane. How do you reflect a geometric shape on a 2-dimensional coordinate plane over the x-axis and over the y-axis? How do you determine which reflection method to use based on the given circumstances? So I am going to show you 2 different ways to do a reflection. So depending on what the question's asking or what you're tasked to do, you may want to use one over the other. Okay, so a reflection is, there are rigid transformations where a geometric shape is moved by a flip over a line of reflection. In this case, our lines of reflection are going to be the x-axis or the y-axis. Reflections do change the position and the orientation of the shape, but do not change the size. Reflections create congruent shapes that are mirror images of the original pre-image. So remember, if they create a congruent shape, which is a shape that is exactly identical to the other, that just means it's been moved in location or it's been moved in orientation. And it's a non-rigid transformation. Remember, there were two types of transformations, non-rigid and rigid. Well, reflections are one of the rigid transformations because it does not change the size, but it does change the position and orientation of the shape. So here we have a triangle PQR, and I'm going to give you two ways to write what has happened to triangle PQR to turn it into triangle P prime, Q prime, and R prime. In words, I would say that this triangle PQR, which is the pre-image, reflected over the x-axis to make the triangle P prime, Q prime, and R prime, which is the image. Now, if you don't understand what I'm saying about image and pre-image, you may want to review the video on Introduction to Transformations before you watch this one. So you may want to go back and watch that one real quick before you start watching translations, reflections, rotations, or dilations. Just to get an idea of what pre-image and image is like. But basically, pre-image is the one we start off with, which is the blue triangle, and the image would be the resulting triangle after the transformation has been taking place. Another way to write this transformation here is that it reflected over the x-axis by writing it as an algebraic rule. So at the bottom here, you see x, y point. So for every x, y point, we're changing the y to its opposite sign. That's what that means down here when you see this negative symbol in front of the y. That doesn't mean that we changed all of the y values to negative. That just means that whatever it started off being, we're going to change it to the opposite. So if it started off being a positive y up here, then it would change to negative. But if it started off down here, for instance, and we transformed it up, or reflected it up, I should say, that's going to make that negative change back to positive on the y. So just know that if you're reflecting it over the x-axis, your y value is going to change to its opposite sign, and that's the only thing that changes on the points. For all three points, by the way, on this triangle. Now we have another set over here, triangle PQR, and this time we're reflecting it over the y-axis. So in words, I would say triangle PQR, which is the pre-image, reflected over the y-axis to make triangle P prime, Q prime, and R prime, which is the image. So it flipped from here to here, and notice when it does flip over these lines of reflection, the orientation changed. Like notice here the Q is on the right, but now it's on the left. So the orientation of where the Q is located did change, and the P and the R too, because now it's on the right and originally it was on the left. Over here, the Q and the PR are still on the right, and the PR is on the left. But notice the R and the P did change places when it flipped over this x-axis. So the P is now not on top, it's on the bottom down here. So again, when that happens, that's changing its orientation as well as its location. Okay, so we're going to reflect it over the y-axis using the rule, and the rule here states that for every xy value, the x value is now going to change to its opposite. So over here, when we did the reflecting over the x-axis, the y value changed to its opposite. Now that we're reflecting over the y-axis, the x value is changing to its opposite. So here's some examples of some reflections that have already been performed. So here we have a pre-image, the gray triangle, and then this reflected image. And it looks to me like it reflected over this middle line here, y-axis. So here's your origin. There's your y-axis. And because it reflected over the y-axis, that means the x value should have changed sign. So if you compare this C, which is 4 comma 4, now it's negative 4 comma 4. So yes, the x value did change to its opposite sign when we reflected it over the y-axis. Same with this 2 comma 2. It is now negative 2 comma 2. And this 5, 1 has now become negative 5, negative 1. Here is an example of a pentagon shape that has been reflected also over the y-axis. Notice the T and the Q have switched places, as well as the R and the S. Now it's SR. That's how we know it was reflected, because if they were in the correct spots, if the Q was here and the T was here, just like in the original, and the R and the S was down here, just like in the original pre-image here, it would be a translation. It would have just been like a slide to the right. But because those letters are in opposite locations now, we know that it changed orientation. So it has to be a reflection. It had to have reflected or flipped over that middle line there, that y-axis. This time we have a point that we are reflecting over the y-axis again, and notice that the x value was negative here, and now it's positive, so it did change that, that one value to its opposite sign. Again, we're reflecting over the y here, and notice that all of my x values have changed to the opposite signs on the ABC triangle versus the A prime, B prime, C prime triangle. And then we have a couple of little shapes here, and it's clear that this one actually reflected over the x-axis. So even without seeing the points, I know that it reflected, because if it translated, it would still look more like an L and not an upside down L or a sideways L. So this one did reflect. This one also reflected, but this one reflected over the y-axis. And if you actually look at these points, you can compare them and see that indeed here the y value changed. So negative 1, 1 is this point right here. So if I wrote negative 1, 1 as my pre-image point, then I should have negative 1 here, because that would have made my y value change to its opposite, which is what we do when we reflect over the x-axis. All right, so rules for reflections. Reflections are expressed in words, math, symbols, numbers, or a combination of both. So let's look at the first one here. The rule for reflecting a geometric shape over the x-axis. For every x, y value, the x stays the same, but the y changes to its opposite sign. That's what this negative y means. That means whatever the y is, you're going to change it to its opposite. So an example would be reflecting coordinate m, which is this coordinate here, which is 4, 5. And we're going to reflect it over the x-axis, and it's going to turn into m prime, which is 4, negative 5. Notice the negative 5 is the only thing that changed from the positive 5. So that y value changed to its opposite, and the point is now located in a different quadrant across this xy axis, or x-axis, excuse me. The next one is your rule for reflecting a geometric shape over the y-axis. So when we do the y-axis, let's take this point B here, which is 6, 7. We're going to reflect it over the y, and this time the x value is going to change sign. So it's going to be a negative 6 instead of a positive 6. And again, if you get zeros in your points, remember 0 cannot be positive or negative. So if that ends up being something that you're supposed to change the sign on, don't change the sign, just leave it as a 0. Sometimes things, when they flip over a line, they kind of land right back on that line if they're already located on the line. How do you do reflection? So there's two methods. We have a counting method. Count the number of unit spaces from the pre-image point to the line of reflection, x-axis or y-axis. Next, count the same number of units on the opposite side of the line of reflection, and then plot and label the new image point. Repeat this process with each point on the shape and then connect the points. So what they're saying to do is they're asking us down here to reflect triangle ABC over the y-axis and use the counting method. Okay, so we're going to use this method here, this first method, to reflect this triangle over the y-axis, which is this line right here. Okay, now to do that, we're going to take each point that's on our shape and we're going to count how many spaces it is from that point to our line of reflection. Okay, so this A, we have 1, 2, 3, 4, 5. It is 5 spaces from our line of reflection, which is this case our y-axis. So now that we know it's 5 spaces from the A point to the line, we have to count another 5 spaces on the other side of the line and then make our A prime point. So we're going to go 1, 2, 3, 4, 5. There's where our A prime point is going to be. So you're going to just write A prime here. Now notice it's going to create a little bit of symmetry here. It should be identically distanced from this line of reflection. Now here we're going to start with the B. The B was 1, 2, 3, 4, 5, 6, 7 spaces away from the line of reflection. So now we're going to count 7 on the other side. So 1, 2, 3, 4, 5, 6, 7. And there's where our B prime point is located. Now let's do the C. The C is 1, 2, 3 spaces from our line of reflection. So let's count 1, 2, 3 on the other side. And there's our C prime point. Connect your points together and you have now successfully reflected triangle ABC over the y-axis line. Now, another way to do reflections is when we do not have a graph. So the counting method is generally the easiest method to use. If you have a graph and a shape that's on the graph, you can just count, make your new points, and connect them. But sometimes you're given just the coordinate points and not the graph. And when that's the case, you need to know the rule. Once you know the two rules over the x-axis and the y-axis, then it's easy to change your points and then relist the points. So our second example here is to reflect rectangle DEFG over the x-axis and to use the rule method. So we're going to use one of these rules, and since we're reflecting over the x-axis, we're going to use the one in orange here because that is over the x-axis. So remember, for every xy point on our shape, the x is going to stay the same, but the y is going to change to its opposite sign. So if you're looking at your points for the original DEFG rectangle, these are our coordinate points. And so the first step is to list your points and then change your y to the opposite sign and list them again. So now we have, instead of a -4 for our D, for D prime, we have a +4. Same with this -4, now it's a +4. -8 turned into +8, and this -8 turned into +8. Notice the x values did not change, only the y, because we reflected over the x-axis. Now it's your turn to try and grow a blossom. So use the counting method to reflect this triangle, triangle JKL, over the y-axis. What are the coordinate points of the pre-image and the image? So remember, the pre-image is our triangle JKL there, the original triangle. So you're going to list those points and then list the points that are going to happen after you reflect it over the y-axis. So I'm going to count to 3. You're going to pause and try this on your own. So 1, 2, 3. Okay, so now I'll give you some answers to this question. This is what your new JKL or J prime, K prime, L prime triangle is going to look like after you reflect it over the y-axis. So notice here it is the same distance from this line of reflection as the J on this side. Same with the K and same with the L's. The pre-image points are listed here, and then the image points are listed. Notice that because we reflected over the y-axis, only the x values changed the signs. Now it's your turn to try and grow a second blossom. So reflecting triangle LMN over the y-axis using the reflection rule, write the coordinate points of the pre-image and the image first. So we've got L, M, and N, and you're going to reflect it over the y-axis using the reflection rule. 1, 2, 3. Okay, so now the pre-image points and the image points are listed in orange. L prime, M prime, and N prime should look like this after reflecting it over the y-axis. Notice the x values are the only values that change to the opposite sign because we reflected over the y. Your turn to try and grow a third blossom. Which axis did rectangle PQRS reflect over, and how do you know? So we have a transformation that occurred here, and it is a reflection, but which axis line did it reflect over? You can use a table, such as this table here, to list your points for the pre-image and the image, and sometimes seeing the points can help you determine which axis line it did indeed reflect over. 1, 2, 3. Okay, hopefully you paused and tried to answer that one on your own. And the answers should be listed here below. You've got -7 and 10 as your pre-image point for P. P prime is -7, -10. Notice the y value changed. So because the y values are changing on all of the points, that means it must have reflected over the x-axis. All right, time to grow a fourth blossom. Was triangle ABCD translated or reflected? How do you know? If it was translated, how many units did it translate and in what direction? If it was reflected, which axis did it reflect over? So I'll ask you to pause and try to answer this question, and I will count to 3. 1, 2, 3. Okay, so this rectangle here was reflected, not translated, over the y-axis. And I know this because the points are flipped on the image and they are exactly the same distance from the opposite side of the y-axis line. So if this had been just a translation to the right, then the A and B would still say A, then B. But it doesn't. The A and B have been flipped around, and so has the C and the D, which means it had to have flipped over the line and not just a slide. So this is definitely a reflection over the y-axis. Okay, your turn to try and grow a blossom. This time we've asked you to find the image points of triangle A prime, B prime, and C prime with the following coordinate points. A is -2, 3, B is 4, 0, and C is -5, -1 after being reflected over the x-axis. So I'm going to pull a table up for you to use. I have listed the original points for the pre-image for you, and now you're just going to try to list the rule and what happened to it. Did it reflect over the y-axis or oh, excuse me, it's asking you to reflect it over the x-axis. So you need to write the rule for that and then the new points. I'm going to count to 3, so go ahead and pause. 1, 2, 3. Okay, so the rule for reflecting over the x-axis is for every xy point, change the y to its opposite sign. So when you list the new points, you're going to list them like this, and notice the y there is now a -3 instead of a +3 on the A. The 0 did not change signs because 0 is neither positive or negative, so that point will still be a 0 for the y value. However, the -1 did change to a +1 on the point C there. All right, our first, define a reflection on a two-dimensional coordinate plane. I would like for you to try to answer this on your own or in your own words, and then I will give you the answer after a count of 3. All right, so reflections are rigid transformations where a geometric shape is moved by a flip over a line of reflection, which is the x-axis or the y-axis. Reflections do change the position and orientation of the shape, but do not change the size. So remember, when it doesn't change the size, it creates a congruent shape. It's identical in angle measurement and side lengths. All right, the second answer the essential question is, how do you reflect a geometric shape over the x-axis and over the y-axis? So again, there are rules for this. The first one is to reflect a shape over the x-axis, change the y value in the ordered pair to its opposite sign, positive or negative, then plot the new point. So to reflect a shape over the x-axis, change the y value to its opposite sign. To reflect a shape over the x-axis, change the y value to its opposite sign. Oh, that's the same thing. Oh, I didn't put your y on there. So let me just write that on there. This should be, to reflect a shape over the y-axis, change the x value. I forgot to change that myself. There we go. That's what it should say. And then the counting method is our other method here. So that is when we count the number of units towards the line of reflection, and then the same number of units on the other side of the line of reflection, and make our points. And then the last question is, how do you determine which reflection method to use based on the given circumstances? So I'll give you guys a count to 3 for that one. All right, the answer is that when you are given a graph, it is usually simpler to use the counting method. Now, you can use the rule method for graphs as well, but generally it takes less time to do it the other way, or it really is a personal preference on that. However, when you're not given a graph, then you can use the reflection rule instead of the counting method. And the reflection rule is just to change the sign of either the x or the y based on which line of reflection you are reflecting your shape over. All right, we have a nice little Horsey here to help us do our vocabulary review. And he's just so cute. He's wearing some blossoms. So coordinate plane, we did go over a coordinate plane is a graph, a grid pattern that is divided into 4 sections by 2 lines, our x-axis and our y-axis. Transformation is a process by which we change a figure, a geometric shape, or we change a point or a line, which is sort of part of a shape, I suppose. And it's where we change it. We can change it in size, location, or orientation. Origin is the 0, 0 center point of our coordinate plane. The x-axis is our horizontal axis, so it goes left, right, right, left. And the y-axis is our line that goes up and down, which is also called vertical. And then our ordered pairs are always listed in X, then Y. The X tells us which direction, left or right, to go, depending on its positive or negative. And the Y tells us how far up or down to go, depending on if it's positive or negative. And a reflection is a type of rigid transformation in which we flip a shape over a line of reflection, which can be any line on our coordinate plane. However, we are using the X and Y axis for these particular rules. All right, great work. And a bouquet of math blossoms have opened up in your mind today. So to further improve your math language skills, remember to practice. If your teacher gives you some practice work, please just do it, because it does help you get better the more you do different types of math problems. And to study at least 10 minutes a day. A good practice is to just kind of review what you learned that day in math. And once you review each day for at least 10 minutes, then by the time the test comes, or if you're being assessed on the material, you've got a good grasp of it if you've been studying all along. Always ask for help if you need it from a friend or a study buddy, but always do this after you try the problems yourself. So it's okay to ask for help, but don't always rely on that help before you try it. So try it yourself first, and then if you get stuck, ask for some assistance. Learn from your mistakes, which means if you correct a mistake and remember that you made it, typically you won't make the same mistake again, and that's a good practice. But if you do happen to make a mistake a couple of times, it's all right. Just try to remember it so that you don't continue to do it. And then always try, never give up, because math can be challenging, which is one of the things I love about it. But if you get kind of frustrated because you've tried a problem 2 or 3 times and you still can't seem to figure it out, take some deep breaths. Maybe go grab some water, a little sunshine, come back to it later on, and sometimes that's enough to kind of get you to understand where you went wrong and to see what may need to be corrected. All right. So first of all, I just want to introduce myself one last time. Thank you again for watching this Math Blossoms video on reflections. Join me for additional math lessons in this series. The next one in this series is called rotations on a coordinate plane, which again is another rigid transformation. And that is the next one you should probably learn before you move on to the non-rigid transformations, which is dilation. So it's now time for me to say it was lovely teaching you math today. Bye-bye.